Assalamualaikum warahmatullahi taala wabarakatuh, and welcome to another video on signal and system analysis. So this time I'm going to explain a mathematical concept that we use to solve a signal which is a periodic signal. Okay, we used to calculate the period, the fundamental period of a periodic signal. Okay, this common multiply, okay, is actually a mathematical concept. Okay, but we are going to use for our signal analysis course. Okay, so here I'm going to explain first about the least common multiply theory or method, and then after that I'm going to explain how you apply this method to solve the fundamental period of a periodic signal. Okay, so let's say for example in this case I have two numbers, 10 and 12, and then I wanted to calculate the least common multiply for these two numbers. Okay, and the method that I'm going to explain here is the method that I take from the signal and system analysis textbook. Okay, so I believe there are other methods that you can use to solve for this common multiply. Okay, so you can use whichever method that you feel comfortable with. You not necessarily have to follow the method that I explained in this video. Okay, but for those of you who have no idea how to solve a least common multiply problems, or have forgotten how to do the least common multiply method, so this method might be applicable to you. Okay, so how do I solve this problem? So the first step that I do is to write these two numbers in terms of their prime factor. Okay, for example, number 10 can be written as 2 times 5. Okay, while 12 can be written as 2 times 2 times 3. Okay, 2 times 2 is 4, and then times 3 will give you 12. Okay, so now that you have reduced these two numbers to their prime factor, the next thing you wanted to do is determine the highest frequency of each number, okay, that appears on this side. Okay, the highest the frequency of each prime numbers. Okay, for example, in this case, we have number 2 and we have number 5. What is their frequency? Okay, number 2 appears in this case only one time, so their frequency is 1. Its frequency is 1. And 5 also appear only one time, so its frequency is 1. For the second case, or for the second number, which is number 12, okay, number 2 appears 2 times. Here you have 2 times 2. Okay, so the frequency is 2. Okay, and number 3 appears only one time, so the frequency is 1. So to calculate the least common multiply for these two numbers, okay, we take the prime number, okay, which is in this case we have number 2, number 3, number 5. Okay, and then we write them in terms of their highest frequency. Okay, for example, for number 2, okay, number 2 appears in in the first case, or in the first number, and also in the second number. But in the first number, it has a frequency of 1. For the second number, 2 has the frequency of 2. Okay, so we take the highest frequency, so 2. For 3 and 1, the highest frequency is 1. Okay, so we can write, and then we multiply this number. Okay, so if I multiply this with my calculator, 2 times 2 to the power of 2 times 3 times 5, okay, I will get 60. Okay, so this is the least common multiply for these two numbers. Okay, let's have a look at another example. Okay, let's say I have 15 and 21 maybe. Okay, and 15 we know, if you reduce to the prime factor, it means 3 times 5. 21, what do we get? If we know 7 times 3 is 21, right? 7 times 3 is 21, and both are prime numbers. So for the first case, we have 3 to the power of 1, okay, because it appears only one time here, and 5 also to the power of 1. And in this case, 7 to the power of 1 and 3 to the power of 1. Okay, so when we write the or when we calculate the least common multiply for these two numbers, okay, it will be, what number do we have? We have number 3, number 5, and number 7. Okay, so 3, the highest power is 1, okay, in both cases, right? So here we have 3, the highest power is 1, or the frequency is 1. Here we also have number 3, the frequency is also 1. Okay, so for number 3, the frequency is 1. Number 5 also 1, number 7 also 1. Okay, so I'm just going to explain. This is also a common mistake done by my student. Okay, because we have number 3 here to the power of 1, and here also number 3 to the power of 1. So instead of writing here 3 to the power of 1, okay, sometimes some of my students will write 3 to the power of 2, which is wrong. Okay, you don't add their frequency. Instead you take the number, okay, with the highest frequency. But in this case, both 3 have the frequency of 1, so we write only 3 to the power of 1. Okay, so if you multiply 3 times 5 times 7, so the least common multiply for this number is 105. Okay, right, so this is for an integer number, so which is straightforward. So what happens if you have non-integer number? Let's say we have 2 over 3 and maybe say 4 over 15. Okay, so which is when you are solving problem related to periodic signal, okay, you will encounter non-integer number. Okay, so in this case, the first step that you wanted to do is change these non-integer numbers, okay, to be integer first by multiplying them with a common number. Okay, so in this case, actually I wanted to change this. Instead of 15, I want it to be 5. Okay, let's say 5. So if we look at the denominator, here we have 3 and we have 5. So we know that we can multiply these two numbers with 15 to make it integer, right? Because here then 3 cancel out, and here we will have 5. 3 times 5, 15. Similarly, these 5 cancel out, and here will be 3. 5 times 3 is 15. So now if we multiply, 2 times 5 will give us 10, 4 times 3 will give us 12. Okay, so now we have similar to the first case. Okay, so in this case is 2 times 5, and here is 2 times 2 times 3. Okay, so if we do just like before, the least common multiply will be 2 to the power of 2, and then we have 3 and we have 5, so it will be 60, right? Just like this one. Okay, so now I'm going to explain how you apply this least common multiply to solve a problem related to periodic signal. Okay, so for example, let's say you are given a periodic signal like this, maybe 10 cos 30 pi t plus 2 sine 50 pi t, for example. Okay, and the question asks you to determine the fundamental frequency, the fundamental period t fundamental frequency f and also angular frequency omega of this g of t. Okay, now if we look at this signal, g of t is the sum of two periodic signal, okay, which is this cosine signal and also this sine signal. Okay, so in order to determine the fundamental period of g of t, okay, we have to calculate the fundamental period of this individual cos and sine signal, and then after that we apply the least common multiply to determine the fundamental period of g of t. So let's say I call this signal g1 of t and I call this g2 of t. Okay, so for g1 of t, which is equals to tan cosine 3 pi t. Now what I can do is make this signal equivalent to the common equation of a sinusoidal signal. So in this case I have cosine, so I'm going to write a cos 2 pi and I'm going to call this f1 of t, okay, because this is the first signal. So what we do next is we take this the one in the bracket to be equal. So we will have 2 pi f1 t equals to 30 pi t. So we can calculate f1, which is equals to 30 pi t over 2 pi t. So these two cancel out and this one will give me 15, right? So I have 15 hertz. Okay. So which means t1 is 1 over 15 second. Okay. Let's have a look at the second one. I'm just going to change color. So for g2 of t, which is equals to 2 sine 50 pi t. Okay. So again I'm going to make it equal to the general equation of a sine function, which is a sine 2 pi, and I'm going to call this f2 of t for the fundamental frequency. So again we take the terms in the bracket to be equal, so that we will have 2 pi f2 of t equals to 50 pi t, right? So that f2 will be 50 pi t divided by 2 pi t. So this cancel out. 50 divided by 2 will give me 25 hertz. So I will have t2 equals to 1 over 25 second. Okay, so you see now I have two numbers, t1 and t2, and they are non-integer. Okay, so I'm going to use the least common multiply method, okay, to find the least common multiply for these two numbers, okay, this number and this number, in order to determine what is the fundamental period of g of t. And so we have 1 over 15 and we also have 1 over 25. Okay, now I'm going to multiply them with a certain number. Let me just change the color. A number, okay, so that we can make this non-integer number an integer. Okay, so what if 15 multiplied by 3? 45. Okay, and let's do this the traditional way. Okay, so 15 times 1 will give me 15. 15 times 2 will give me 30, and 15 times 3 will give me 45. 15 times 4 will give me 60. Now let's have a look at 25 times 1 is 25, times 2 will be 50, times 3 will be 75. Okay, so what about this one? 5. Right, 75. Now we have two numbers, okay, 75 and 75, that we can use to multiply these two numbers. Okay, so we multiply this with 75 and 75. Okay, so that this 15 cancel and it will give me here 5. The 25 also cancel and it will give me over here 3. 1 times 5 is 5, 1 times 3 is 3. So they are already how to say, a prime number. 5 and 3 is already a prime number. Okay, so the least common multiply is 5 times 3, which is 15. Okay, now the fundamental period will be 15, but remember, at the beginning here we multiply the two numbers with 75 in order to make them an integer number. Okay, because the least common multiply method requires an integer number. Okay, so now to calculate the fundamental period of g of t, okay, we take this the least common multiply number, and then we have to divide it by 75. Okay, so this will be 1 over 5. Okay, second. So the fundamental period for g of t is 1 over 5 second. And so the fundamental frequency for g of t, okay, which is this signal, okay, that is the signal that we get by summing this cos and sine function, will be 1 over t equals to 5 Hertz, and then the radial frequency is 2 pi f. Okay, so it will be 2 times 5, so 10 pi radian per second. Okay, so I hope it's clear on the least common multiply method and how you apply that method to solve equation related to periodic signal. Okay, so I will see you again in another video where I will discuss more sample problems related to signal and system analysis. Thank you.